Now I want you to look at this very challenging problem. The first thing you're going to want to do is locate the base and the height. You see me thinking? Because this one's hard. So the first thing you need to do is locate the base and the height. If I try the base right here, I can't actually count how long it is. It doesn't lie neatly on my graph. So if I lay the base right here, well, I can't count it either. It still doesn't lay neatly on my graph. So it seems like a nearly impossible problem. But it's actually not. You just have to think differently. If I were to outline a parallelogram, a nice and easy parallelogram, I can count the base at the bottom, which is 12, and the height here, which is 12. And 12 times 12 is 144. So I know the whole red area is 144. And I know if there's 144 units here, I can subtract the areas. Check this out. If you have a very flexible mind, you can see that I've actually drawn 3 triangles. And this yellow triangle has a very easy base and height to count. And this green triangle has a very easy base and height to count. And this purple triangle has a very easy base and height to count. Which means that purple triangle has a height of 12 and a base of 6, and I just divide that by 2. That purple triangle is 36 square units. And if I look over at that yellow triangle, then I know it has a base of 12 and a height of 7, and I divide it by 2. We always take a triangle and divide it by 2, which means 12 times 7 divided by 2 is 42. So that green triangle, what is the base of that green triangle? Pause the video and see if you can tell me the base and the height of that green triangle. So in order to figure out the area of that blue triangle, which seems so impossible before, all I have to do is a little creative thinking and use a little imagination. Now I will take that big parallelogram, that's 144 units, and subtract the purple triangle, the orange triangle, and the green triangle, and I get a grand total of, well, you're going to have to do that part on your own. With a little imagination, I can figure out the impossible. Using the formulas of base and height for a parallelogram, and base and height divided by 2 for a triangle is what's going to help me. When you look at this 3-dimensional polyhedron, when you look at this square pyramid, it seems pretty impossible. But actually, if I could figure out that last one, I can figure out something else. The area of a triangle is half of the base and height. But they only told me one triangle here. But if I know that this one is 8, and then this one must be 8, and this one must be 8, and this one must be 8. So I have all the bases of all those triangles now. Look, and here's the height. If this one is 11, then this one's 11, and this one's 11, and the back side is 11. If the height of a side is 11, I can deduce that all the sides are 11. Watch this. So this seems pretty hard, but really it's just 4 triangles and 1 square. I can multiply the base and the height and divide by 2 to get 1 triangle. 8 times 11 divided by 2 is 44. There's 1 triangle face that's 44, and there's the back side, and the front side, and the left side. So I could just, oh wait, I think I forgot the square. I need to multiply the base and height of that bottom square, which is 8 times 8. And 8 times 8 is 64. So if I have the area of 4 of those triangles and 1 of those squares, I have the entire surface area. I just need to add them up. And that would give me the surface area of the entire pyramid. So you figure that part on your own and you give me the answer. And that's it. Like, that's it. So today we did the hardest problems in your math packet. And I think with a little bit of practice, you can solve the surface area of any pyramid or any prism.